For this, generally this total strain amplitude, let us this epsilon t by 2, this total strain amplitude can be written as elastic strain amplitude plus, you can say, plastic strain amplitude, which can be written as sigma f by E. So, you see sigma f by E is called what it is called fracture stress amplitude, this you should keep it in mind, into 2 n to the power c, correct, plus another one is epsilon f amplitude, epsilon f amplitude you can write into 2 n to the power what it is called b. So, this is generally the equation for this total strain zone, which is the combined effect of elastic zone and plastic zone. This you should keep it in mind. So, what is Coffin equation, which I am representing in equation 2? It generally represent the relationship between number of cycle reversal versus a plastic strain amplitude, okay, with a one constant, correct, which I am showing in equation, and Buskin equation also I have shown. So, these two equations generally used for two different zone. Generally, for in case of low cycle fatigue zone, Coffin law of fatigue is used, where generally plastic deformation is the prime zone, whereas generally Buskin equation is for high cycle fatigue zone, where generally elastic deformation or elastic strain is the main zone. What I am telling, understand, this you should keep it in mind. Now, we will discuss about what it is called mean stress correction related concept. Generally, here I am going to show what is mean stress correction. Mean stress correction is generally we use once a, you can say, component is subjected to fluctuating types of loading in the sense, let us consider a component is subjected to fluctuating, this is our 0 line, this is T, this is actually 0 line, let this is our stress amplitude or stress value. So, you see this, if we draw, you see it has a maximum value sigma max and it has a minimum value sigma min. So, for this case what we can observe, this has a mean value. What is mean value? We know sigma mean, if it is subjected to fluctuating types of loading, generally then for this fluctuating types of loading, there we can observe a mean value as well as a amplitude value. What is mean value? Mean value means sigma max plus sigma min divided by 2, correct. So, this mean value is here, let us consider is a positive mean, let us consider it is a positive mean. Okay. Now, once a component subjected to this types of fluctuating loading, then what happens, we can get a amplitude as well as a we can get a mean also. So, for that types of fluctuating loading, we can convert to what it say equivalent stress cycle where mean stress is 0. So, to convert a positive or negative mean stress value into a form of 0 mean stress cycle, that concept is used in case of mean stress correction concept. What I am telling, understand how it is, that I am going to show. So, generally this positive mean stress, once we convert, then what we can say, we can get a equivalent what is called reverse types of stress cycle. Reverse types of stress cycle, what is reverse stress cycle? Reverse stress cycle means which has a 0 mean, but which has higher maximum and minimum value. What I am telling under this, we can convert into a. So, here let us, this is our sigma m or mean, which is 0, but it has a sigma max value. This sigma max value let us is sigma max 1, and it has a sigma mean value, let us sigma mean 1. This sigma max 1 or sigma mean 1 which is much higher than what it is called this sigma max and sigma mean value. Higher amplitude, you can say higher amplitude stress level, this we can convert where the mean stress value is 0. But once what happens, once we directly convert these types of stress cycle, that means fluctuating stress cycle, into a reverse types of stress, this is actually completely reverse cycle, completely reverse cycle. This is actually fluctuating types of loading case. So, once we convert these things into a equivalent completely reverse cycle, then what happens, though you see our effect will be same, but it is observed that if we directly convert these types of way, then what happens, our cumulative damage become quite higher than this normal fluctuating case in case of completely reverse cycle with higher amplitude. For that reason, generally what happens, to correct this damage effect, generally there we use another approach. There we combine generally what is called the effect, or there we combine what is called Goodman equation. By using the Goodman equation concept, there we convert this fluctuating stress into a what in the form, into a completely reverse stress by with the help of what is called Goodman line. If we use the combined effect of Goodman line and this completely reverse stress cycle, it is observed that whatever the damage we are getting, that is quite acceptable with what is called or comparable with actual fluctuating types of loading case. That related things I will discuss in subsequent slide. So, before going to discuss these things, what you can observe generally in case of fatigue, generally you can observe 3 different types of SN curve for same material. How? Let us little bit I am showing. So, 3 different types of approach you can see, that this is our log fatigue strength versus log number of cycle. If we draw, so what happens, 3 types of case we can observe. In one case, what there can be what is called 0 mean stress, that means this is our time, this is our stress value. Here you can say in this case, here let us sigma max amplitude is equal to your sigma mean amplitude, completely reverse types of cycle, here mean stress is 0. So, for this case you can get a what it is called stress versus strain curve, which can be look like this. This is the one curve where sigma mean equal to 0. This is one case where completely reverse types of loading is there. Another case can be a fluctuating types of loading, sigma versus epsilon, where there is a positive mean stress, where there is a sigma m, this sigma m is positive. Positive means which is tensile in nature. So, we know in case of tensile types of mean stress case, generally fatigue strength reduce. So, its load bearing capacity due to fatigue it's reduced. So, its number of cycle reduce. So, in this case we can get a SN curve which I am showing in this dotted line. Let us consider this is line 2 you can say, and this is line 1. Okay. So, in this case you can observe that less number of cycle you are getting. So, here you can say here fatigue life decrease. So, this is the tensile types of tension types of mean stress, where you can say fatigue life. So, you can say here decrease fatigue life, decrease fatigue life, correct, in case of tensile case. Why? Because if a body is subjected to tensile, then what happens, there is a chance of more crack opening tendency. That means crack propagation will increase. What I am telling, understand? That is why its life will decrease. This you should keep it in mind. So, in another case, so this is case number 1, this is case number 2, and in another case also we can observe, in this case where the mean stress is compressive in nature, where the mean stress is compressive in nature. So, this is the case number 3, where the mean stress, let us consider, this is our 0 line, okay, this is the 0 line. In this case, here the mean stress sigma m is, let us, negative or compressive in nature. So, if it is compressive types of mean stress which due to fluctuating loading, then what happens, its fatigue life increase. What I am telling, understand? So, that we can plot, that you can plot at top side here I am showing. If we draw it, you can get a curve which is looks like this. Let this is curve number 3. So, in this curve number 3, it is generally compressive types of mean stress, where generally fatigue life increase. This you should keep it in mind. So, these 3 different case you can observe. What I am telling, understand, due to different mean stress level. What I am telling, understand. So, next case what we are going to show, if the mean stress is 0, converting this positive mean stress and negative mean stress, then how the fatigue life will be, that related things now we are going to discuss. So, first of all we should know what is mean stress correction. So, mean stress correction means, this mean stress correction is used to transform a stress cycle to an equivalent stress cycle with 0 mean stress. That means, a fluctuating stress cycle which have a mean stress value, that we are converting to a reverse types of stress cycle with 0 mean stress. This which I have already shown in previous slide itself. Whatever the transformed stress cycle is there, where the mean stress is 0, this must still contain the same fatigue damage potential. This you should keep it in mind. So, this we should convert into such a way, that means this fluctuating stress we need to convert in a reverse types of stress cycle. It should be such a way so that it should contain the same fatigue damage potential. If it will not same, then this correction is not accurate. That is why what happens, whatever the plot I have shown, like what happens, let us consider, this is a positive mean stress, this is our time versus stress, it has a positive mean stress. This positive mean stress we can convert into a reverse cycle, where generally this should have a high amplitude, comparatively high amplitude than what it is called this stress. What I am telling, understand. So, if we do like this directly, then what happens, that I am going to show. So, in this figure what we can observe, cycle with positive mean stress is transformed to a higher amplitude alternating stress, or you can say alternating stress means fully reverse stress cycle with 0 mean stress. 0 mean stress means reverse cycle. This is completely reverse cycle. What I am telling, understand. So, if using alternating stress only, or you can say if using this reverse cycle only, alternating, or you can say completely reverse cycle only, then what we can observe, the cycle accumulate more damage. If directly we convert this thing, and then what we it observe, it accumulate more damage. That is why here I have written, to get the correct equivalent fatigue damage, the amplitude of the stress cycle is changed using a Goodman-High diagram and stress ratio information. This phenomena is known as mean stress correction. Let us figure 2. In this figure 2, whatever the diagram I have shown, in this case whatever the fatigue damage we will get, that generally gives us quite high fatigue damage compared to these fluctuating types of loading. What I am telling, if we directly convert these things. For that reason, to get the correct equivalent fatigue damage, here we add the phenomena of what it is called Goodman equation and stress ratio. What I am telling, understand? By this phenomena we can get correct equivalent fatigue damage with the conversion of this fluctuating loading to a completely reverse loading. How it is, that I am going to discuss in subsequent slide. So, to calculate the what is called equivalent stress cycle with zero mean, the Goodman-High equation is used. Now, Goodman-High equation here I am showing. What is Goodman-High equation? In case of alternating loading case, what we observe that generally this axis represent our mean stress, this axis represent our amplitude of the stress. They are generally from endurance strength to ultimate stress or ultimate strength. If we draw a line, that is generally called, this line is called Goodman line. So, this Goodman line concept will be used to correct this mean stress effect in what is called fatigue damage. How, that I am going to show. Here I am just showing one by one, then it will be very clear to you. Let us consider for a particular fluctuating types of loading case, let this is T versus stress. So, for a let us positive types of fluctuating load is there. So, for this, here we will get a mean value and here we will get a amplitude also. So, for this case, let this is our sigma max and this is our sigma mean. So, from this generally what we can get? We can get sigma amplitude equal to, you can say, sigma max minus sigma mean by 2, and sigma mean we can get as sigma max plus sigma mean by 2. This is very well known to you. So, if we plot this thing in this, what is called diagram, then we can get, let us consider we get a point where let this point I am representing in terms of x. Here you see, let this x point we got where there is a value sigma m comma sigma a, correct. This generally for this we have a mean stress as well as what it is called, we have a amplitude. This mean stress we can correct where generally the mean stress we can correct, that means this alternating stress cycle we can convert to a stress cycle which will have what is called zero mean stress. For that what we need to do? Let us consider these are the steps we need to follow. This is our sigma mean, this is our sigma amplitude. So, we already got this Goodman equation, that is AC versus SUT. Now, one point x we got due to what is called sigma m and sigma a. Now, what we need to do here? Here we need to do a line, this black dotted line we need to draw. This black dotted line should pass through this point x. What I am telling, understand? and this black dotted line which is parallel to, always you should keep, this is parallel to what it is called Goodman line, Goodman line. Okay. So, once we draw a line, then this line cut the ordinate of this what is called stress amplitude, ordinate of this stress amplitude at a point, let us consider P. In this point P, it will cut. So, at this point P, whatever the stress we will get, that stress will be considered as the amplitude of that what is called conversion of this fluctuating stress into a zero mean stress value. What I am telling, understand? This you should keep it in mind. So, at this P point, whatever the SF we will get, this SF will be the, you can say, amplitude, is this SF will be the amplitude of completely reverse cycle. So, once it is completely reverse cycle, then what happen? That is completely reverse cycle, that is mean stress should be equal to 0. What I am telling, understand? So, at this P point, whatever the stress we will get, this stress generally will be considered as the stress amplitude of completely reverse cycle. If we consider that completely reverse cycle with a amplitude SF, then what happens? Whatever the damage we will get, that is quite equivalent to the damage due to this fluctuating types of loading. So, these fluctuating types of loading you can convert, that is, this is the case once the mean stress is positive, once the mean stress is positive, that means sigma m is positive. For this case, generally this is the step we need to follow to correct the mean stress effect. This you should keep it in mind. How? First of all, we need to point this sigma m versus sigma amplitude. Through this point we need to draw a line which is parallel to Goodman line. That parallel line which cut the ordinate at a point P, that point whatever the stress it will give, that is considered as a stress amplitude of completely reverse cycle. That means, based on these things, if we draw the what is called, if we draw the reverse cycle, if we draw the reverse cycle where amplitude equal to, you can say, SF at point P, then whatever the effect you will get, that is equivalent to the effect of this positive mean stress. This you should keep it in mind. Okay. So, this is the completely reverse stress amplitude where mean stress equal to 0. So, this way generally we convert or correct the mean stress effect using Goodman diagram. This you should get. This is for positive types of mean stress. Now, once it is what is called negative types of mean stress, then how we can correct this effect, that I am going to show. Now, we will discuss, consider a case where the mean stress value is negative in nature. What I am telling, understand? That means, with net compression, that I am going to show now. So, sometimes the reverse types of or fluctuating types of stress cycle can produce the mean stress which is negative in nature. This is your 0 line. Here let us consider the stress cycle is like this. So, here once you find the mean stress, you will find this mean stress is negative. This mean stress is negative in nature. And so, now we will plot the what is called amplitude and mean stress due to this compressive types of fluctuating loading if we plot the thing, let this is our mean stress axis and this is our amplitude axis. So, for this case let us consider we get a point, this x point where there is negative mean stress and there is some amplitude. What I am telling, understand? Let us consider this point x we got. So, here generally we know these things, endurance strength, Goodman diagram we know, endurance strength versus ultimate strength. So, this is our Goodman line, or this is also called Goodman height diagram. So, for this case how to correct this mean stress effect, negative mean stress effect? For this generally what we need to do, we need to draw a parallel line, we need to draw a parallel line which I am showing by dotted line. This parallel line should what it is called parallel to Goodman line. So, this dotted line is parallel. So, this dotted line which cut the ordinate of this stress amplitude versus stress mean curve at a point, let us consider P. At that point P, whatever the stress amplitude we will get, let S F A, based on this stress amplitude, if we draw a what is called, if we draw a completely reverse stress cycle, then whatever the cycle we will get, that is the mean stress correction cycle, where mean stress will be 0. So, this compressive alternative stress case, what you observe? You observe that you can get a stress level whose amplitude is, you can say, lower than the endurance strength value. So, based on this diagram, what happens if we draw a completely reverse cycle? If we draw a completely reverse cycle with amplitude, you can say with amplitude, this sigma A with amplitude equal to, you can say, S F A, what I am telling, understand? That will give the corrected reverse cycle with mean stress equal to 0. So, whatever the effect of this, let this is our A diagram which is completely compressive types of fluctuating load, and this B diagram is, let us completely reverse types of loading. So, whatever the effect of this A diagram will be, the effect of B diagram also will be, you can say, same. That is why here when projected from a cycle in compression, then a load time history would have a lower alternating stress. This you should keep it in mind, where mean stress is considered as 0. This you should keep it in mind. So, this way generally we can what it is called correct the mean stress. That means alternating stress cycle we are converting to completely reverse cycle with 0 mean stress. Now, another case, in case of negative types of what it is called stress cycle, another case also we can observe, where generally let us consider the compressive stress value, compressive mean stress value is very high. So, for the case of compressive stress value is quite high, that case generally, in that case we use some other approach to correct that mean stress effect. How? That I am going to show. So, let us consider this is a compressive types of alternating stress cycle. Let us consider this compressive types of alternating stress cycle. So, this will have a, let us very high, you can say, mean stress, and this will have a amplitude also, this will have a amplitude also from here to here, whatever the value, generally it is called generally amplitude. So, for this case, if we draw the what it is called mean versus amplitude, in this case what we can observe that, let us consider it has high mean stress and it has a amplitude. Let this point is coming here, whereas we know this Goodman diagram is, this is the Goodman diagram. Okay. So, endurance strength versus ultimate strength. Okay. So, for this point, if we draw a parallel line similar to Goodman diagram, then what we can observe that it cut this amplitude at point P which have a negative amplitude, correct. This thing generally is not possible, negative amplitude, what I am telling, understand. So, for this case generally what we used to do, we use separate procedure to correct the mean stress effect. For this generally what we need to do, little bit I am explaining. For this case let us consider this x point which have a mean value, negative mean value and a amplitude. Okay. So, this case once it cut in negative side of this amplitude versus mean stress curve, in this case generally to correct the mean stress effect we use another procedure. What is this procedure, that I am going to show. So, for that case generally we need to divide it, this negative side, we need to draw a line which is 45 degree with ordinate as well as abscissa, that means this is 45 degree. Okay. This 45 degree line, for this generally what happens, what we need to do, for this first of all from x we need to draw a horizontal line which is up to this 45 degree line. So, we need to draw a horizontal line up to what, this 45 degree line. So, after that generally we need to draw a line which is parallel to what, Goodman line. So, this line you can say parallel to Goodman line, whereas first this line which is parallel to, you can say abscissa, which is parallel to abscissa, or you can say mean stress line. This you should keep it in mind. So, from x first of all we need to draw a line which is parallel to abscissa up to this 45 degree line, what I am telling, understand, in this negative axis size up to this, what, let us consider this is your O, this is our M, OM line. Up to OM line we need to draw a parallel to abscissa or parallel to mean stress line. Then we need to, from that point, let us consider this point is N. So, x to n we need to draw. So, here I am writing x to n, we need to draw a parallel to mean stress line, or you can say parallel to abscissa. After that generally we need to draw another line, that is, let us consider n to n1. So, n to n1 we should parallel to n to n1 which is parallel to Goodman line. So, this n to n1 line which cut the amplitude axis at a point, let us consider P. So, at this P point, whatever the amplitude we will get at P point, this will give us the stress amplitude of completely reverse cycle. This you should keep it in mind. So, by considering this stress amplitude, if we draw a what is called reverse cycle which have a amplitude SAP, you can say with mean stress equal to 0. This is the completely reverse cycle with mean stress equal to 0, conversion from this, you can say this cycle. This way if we do the what is called analysis, whatever the damage you will get, that is quite corrected damage, that is why it is called mean stress correction with Goodman diagram for compressive types of stress amplitude. This you should keep it in mind. So, this all about today's lecture. So, these are the references which I have followed for this lecture. Thank you.